Most common coliform is who? E. coli. That's where coli comes from, coliform. E. coli is the most common coliform. And also, one of the most common causes of urinary tract infections, because E. coli comes from the back door, and sometimes it sneaks up the front door. Serratia is also considered a coliform. Why? It's in family Enterobacteriaceae with E. coli. And what's unique about Serratia when you see it on a Petri plate?
It's reddish.
Red pigment, right. And what's the organism, the bacterium that causes bubonic plague? Yersinia pestis, good. And Pseudomonas has a capsule, and many times the capsules merge together and it swarms and causes a spreading infection behind a biofilm. That biofilm ability of Pseudomonas, the ability to form a biofilm, what does it do for Pseudomonas? Makes it more antibiotic resistant. Good. Okay, know that one. Sometimes you'll get a little question. I'll just give you a little scenario, and then you kind of have to figure out what the hell is she talking about? What bacteria might be causing this infection? I'll give you a color. I'll give you a location in the body. A little, maybe tiny little one-word history about the patient or something, and you kind of have to figure it out what it is. Alrighty. Can you pick out from a list which ones are gram-positive and which ones are gram-negative? You know, urinary tract infections can be caused by gram-positive or gram-negative bacteria. E. coli's gram-negative comes from poop. Enterococcus faecium or fecalis is gram-positive, comes from poop. How about Staphylococcus from your skin? The most common UTI is caused by Staphylococcus saprophyticus. They don't really know if it comes from your skin or from your feces or both. But you can have gram-positive UTIs, you can have gram-negative UTIs, you can have a mixed UTI. So when they get your urine sample, how do I know? As soon as you pee in the cup and you hand it to the nurse and she grabs it, how does she know if you have a UTI or not?
Cloudy.
Cloudy. What's the term for cloudy?
Turbidity.
Right? Biggest sign of microbial growth in broth. Urine is like a broth. It's cloudy. Your urine should be clear. It's a sterile fluid. If you pee and you saved your urine in a cup just for kicks and giggles, after a while it's going to get stinky, right? Why do you think it gets stinky?
Bacteria.
Because the bacteria on your skin got in the urine when you peed in the cup because you didn't wipe first with one of those sterile wipes. You know, when they say get a clean catch, they give you little wipes to wipe everything off with first. So urine is sterile in your body, but when it exits your body, it picks up bacteria from your skin. And then there are, you know, some nutritious chemicals in the urine that the bacteria can start replicating on, and then your urine begins to smell because now it's got bacteria in it from your skin. But inside your body, it's odorless, and except for maybe the nutrients that are in it, but it doesn't have any infections inside your body unless you got infected with something like Staphylococcus saprophyticus. So you can get different kinds of urinary tract infections. In the hospital, you're more likely to get Pseudomonas urinary tract infections. At home, you're more likely to get E. coli, Enterococcus from your poop, or Staphylococcus from your skin. And, okay, which was the disease, this is a hard one, I told you about where it was the bacteria were in the moisture droplets, the mist from the air conditioner. Legionnaire's disease, right, Legionella. Also could be in the mist from hot tubs, also could be in the mist from those sprayers at the produce, at the supermarket. So they have to be very careful with those misters, because it grows Legionella, Legionnaire's disease. Remember Legionnaire's disease? The Legionnaires nailed the droplets from the air conditioner when I was going to Philadelphia. And, okay, if I'm going to autoclave something like my nutrient broth to make it sterile, it's going to kill viruses, proteins, molds, mold spores, But what's the hardest thing to kill? Endospores. Good. Okay, where do antibiotics come from? Usually other microorganisms like actinomycetes, streptomycetes, penicillium, which is fungi or mold. And if I'm, let's say I run a tattoo parlor and I have to autoclave my needles, how do I check and make sure my autoclave's working and report it back to the health department?
They're gonna send you the test, right?
They're gonna send me spores of bacillus of some kind. It's actually, let me see, Styrothermophilus. So heat-loving, so these are really heat-loving bacteria, and the endospores are also heat-loving. So you're gonna get a little package of endospores of some bacillus, and you're gonna have to autoclave it, and then when you send it back to the health department, they try to culture it, and if it doesn't grow, that means you killed the endospores. But if it grows, your autoclave's not working strong enough to kill the endospores. And who is the guy who came up with the concept of chemotherapy when he devised a magic bullet drug for syphilis? Early magic bullet for syphilis. Good. And what happens when you take an antibiotic and it disturbs the balance of your normal microbiota or your normal flora? What happens? Take an antibiotic, throws my balance out of whack, what do I get? An opportunistic infection. C. diff is one. C. diff can get so bad that you get pseudomembranous colitis. You will see pseudomembranous colitis on your chest from C. diff. That means your colon's all inflamed because of the action of the bacteria. And pseudomembranous is false membrane, and pieces of it will come sloughing off. And forgot what I was going to say. Oh yeah, how about Candida? Candidiasis, you can get a yeast infection, right? Sometimes you can get secondary infections that are opportunists also. So let's say you have Candida and it irritates your skin and makes it cracked and raw, and then bacteria from the environment get in and cause an infection. That's a secondary infection, but it's also kind of an opportunist because it's taking advantage of the opportunity created by the first infection. That's why it's called secondary infection. Okay. Got that one. Don't forget your bacterial shapes and arrangements. Tetrad, Sarcina, Staphylos, Strepto, Bacillus, Cocci, Vibrio, Spirochetes, Spirillum. What if my bacteria are killed by oxygen? What am I going to put my patient in? Hyperbaric chamber. Baric means pressure. Barophilic means loves high pressure. Capnophilic means likes high CO2. Either one of those is the answer, but they do come up in your textbook. That's why they're on the test. You know psychrophilic cold, mesophilic human body temperature, thermophilic warmer than that, neutrophilic, acidophilic, whatever. Capnophilic means CO2, like CO2, and barophilic means like high pressure. A hyperbaric chamber means high oxygen pressure. I'm going to kill Clostridium because they're anaerobes and they don't like the high oxygen pressure. How am I going to culture my Clostridium? I'm going to need an anaerobic chamber of some kind, like a candle jar or something like that. Alrighty. Don't forget Proteus vulgaris is flagellated all the way around. I'll show you a picture real quick. And what family is Proteus vulgaris in? Same family as E. coli. Oh, I love this picture. It'll come up. Okay. You remember your different bacteria? Who's gram-positive, who's gram-negative? E. coli, who's gram-negative? Staphylococcus epidermidis, gram-positive. Serratia marcescens, gram-negative. Bacillus subtilis was gram-positive. Who else do we have in the lab? Can't remember. Did I get them all? What was it? Yeah, Micrococcus luteus. Anything with coccus in the name is going to be gram-positive. Okay, this is a Petri plate that they stabbed in the middle. So instead of using an inoculating loop, they use an inoculating needle. Just a straight wire. They sterilize it, let it cool, touch it to a colony of bacteria, and then stab it right in the center of this plate. So the first generation of bacteria are at the center of the colony. And this plate's just going to have one big colony on it, right? So the center of the colony is the oldest. The next generation, look, they must swarm. They have flagella. They can literally swim over the top of the agar. So the first generation swarmed out, second generation swarmed out, so that's showing swarming on a Petri plate of Proteus vulgaris, and here it is. It's got hairy flagella, hairy black flagella all the way around it. This one's brighter. See, it's like cousin it. Proteus vulgaris, think of cousin it.
That looks like a centipede.
Yeah, a hairy centipede. Really hairy one. Anyway, I love to ask that question just because vulgaris, Proteus vulgaris. As soon as you hear vulgar, you're thinking, oh, black hairy flagella all the way around it. Alrighty, let me just make sure. Okay, you know about that one. Oh, don't forget, one of my favorite ones, Gardnerella vaginalis. Gram-negative bacteria. Spelled fishy down there. Better find out what it is. A lot of things can be living down there. It's an overgrowth, just like Candida, but this is an overgrowth of bacteria, Gardnerella bacteria.